Alright, so now that we have our tracing, I just took measurements off of my tracing and off the back of the gearbox, and we're now going to draw it up in Fusion 360, and then we'll go out and we'll machine our spacer, and I'll show you how it's done. Now, as you can see, I've already drawn this up and did the machining, but I want to show you how we did it in Fusion 360. So let's get started. Alright guys, so here we are in Fusion 360, and this is our head spacer for the Precision Matthews 727. Pretty simple, straightforward design. So let's get started and we'll see how this was drawn. So the first thing we want to do is create a cylinder. We want to put it on, this is our Z-axis, this blue line. So I want to put it on this plane here. And according to our sketch, it's 148 millimeters. Right, and we need to make this 1 inch and 1/8, which is 28.525 millimeters. Alright, now we have our basic cylinder. We'll go back and create a second cylinder, and we want to put it on this space here, and we want to put it in the center, and this is going to be our bump out, which is going to go into our spindle, and that is 59.98 millimeters, and it is going to be 1/8 of an inch, which is 3.175 millimeters. Alright, that's our bump out. And then let's go around to the back side. Right click and we can repeat cylinder. And we'll put it on that surface there. And again, 59.98. Okay, and then this time we want to go in and cut that out. And we want to go 8 millimeters. Alright, pretty straightforward and simple. Let's do a chamfer and knock some of these corners off. So go to Modify, Chamfer, and we'll select this edge. Hold down Control, select that edge. Go around to this side, Control, select that edge, and this edge. And then we just need to put a slight chamfer on there. Let's do 0.7. Looks pretty good. Click OK. Now we need to drill some holes. Next we want to go to Sketch and create a sketch. We can create it on this plane here. Alright, and then hit L for line. I'm going to go to the center. We're going to go down 90 degrees and we're going to go 61 millimeters. Then we're going to go back to the center, hit L, another line, 61 millimeters. And 61 millimeters this way. Okay, then we want to stop our sketch And then we want to go to create hole. We want to do multiple holes. Here, here, and here. These holes are 13 millimeters in diameter. And 30 millimeters deep is fine. It goes all the way through. Click OK. Turn our sketch off. And there we go. We have our completed spacer. Didn't take very long. Now let's do some cam function for it. So we go up to Model, Cam, New Setup. We're going to be doing turning. Check this spun profile with it on. Because it has the holes in here, if it's a spun profile, 360 knows that this can't be machined with this spinning. So if you check spun profile, otherwise it'll try to go down into this hole. I've had it do that before, so for some reason it does that. I couldn't figure it out, but if you check spun profile, you won't have any issues there. The stock is 6 inches and it's 1.25 inches long. Okay. Now the first operation here, let's get this oriented right. Okay. Let me tilt it just a little bit. So we want to turn profile. I'm going to be using tool number 2. This is a SDLC tool holder. Go up here to setup. Let me click this arrow and it'll put the X back down here. There we go. Alright, we're going to be going at 1200 RPMs. We're going to be using surface velocity. We're going to use feed per revolution. My feed rate is going to be 0.01. Okay. Geometry. Confinement. I want to confine it to this area. This area. Right here. Right here. Alright, let's see how that works out. Step over 0.01. Finish feed rate 0.05. Step down 0.01. Okay, that's on the thing. There we go. Click OK, see what happens. There we go, we got it oriented in the right spot. Alright, there we go. Alright, let's see, did that? Let's see what we got here. Alright. Okay. It's coming all the way up to this curve right here, but it's not machining any of this, and that's good and bad. I need this machined as well. However, it's going to be into a 4-jaw chuck, so I can only do about half of it, and then I'll do the other half when I machine the backside. So in order to get it to only do half, I'm going to go up to geometry right here, and I'm going to use this backside stock offset, and I'm going to put 0.65, and also for confinement I'm going to add this additional face here. Okay, something went wrong there, So let's go back and check it. Maybe a negative. How about that? So now we'll machine this and then pull out. There we go. Alright, now let's simulate this. See what we've got. Alright, pretty straightforward. We can also get this with a facing. However, I'll do that in a different operation. So let's do turning facing. Let's actually, we can use the same tool. That's all good. We'll face that whole side there. That all looks good. Alright, let's see what this operation looks like. Alright, basics facing there. Now we can put that in the front. Well, that takes care of this particular setup right here. Now we need to machine the back side. So let's get that set up. So we're going to do a setup number 2. And we're going to pop that over to this side. Move that over and that over. There we go. It's going to be a turning operation, a spun profile. That looks pretty good. Okay, change the stock. It's 1.25. Click OK. Alright, that looks good. So the first thing we want to do is, again, we want to face this. Tool number 2 is fine. All the parameters from our last are in there. Let's see if it faces this stock. Looks like it's fine. Alright. And then our next operation will be a profile. Now for this one I'm going to be using a boring bar, which is tool number 13. So we got to change this to boring. Click OK. This is a DCLNR. Click OK. Our tool orientation, you can see how it is. It's already set up because this particular tool is set for that orientation. I'm going to be doing speed per revolution, 0.01. Our RPMs are 1200. They're actually 1280, but okay, I forgot to set up my confinement here. Here, here, and here. Alright. Let's see. 0.01. Finish feed rate 0.005. Maximum step down 0.01. Alright. See how that looks? It's giving me an error here. Invalid tool angles. Okay, let's see what's wrong with that. Let's go back to edit. Okay, my pass direction, I need to set that up to 90. I need to change this to inside profiling, and then that will be front to back. Okay. Let's see what we've got now. Much better. Okay, so you can see that with this operation, it starts out from the outside, and then it's going to face this, and I don't want it to face it with this tool. You can have it just face it. If you want. But if you don't want it to face it, then you can edit it and move your clearance. Now you got to be real careful with this because your outside diameter is here and you don't want to cause any problems. Okay. Click OK. There it goes. Alright, so now you can see that it's just going to start right here and only do this particular part. Okay. So let's see what happens if we simulate the whole program. Happened a little too fast. Hold on. Okay. You just got to make sure that you're going to have clearance for your tool if you're going to do it this way. One more operation. We need to get this down to the right diameter. So, need to profile. Tool number 2. Okay. Oh, that looks good. Change this to. Alright. You just want to keep it confined to this area right here and this chamfer. Okay. Backside offset. Let's do point minus 0.65. Okay. There we go. Let's see. Change the step over. Bench speed rate on. There we go. That looks good. Let's give this just a little more. Alright, that should be good. Now I'm going to move that operation up to the front here, and we should be good. So that wraps up the cam operation. Now you just want to post these processes. So let me show you how I post my processes. So I'll go up to setup here, and I want to post process. You want to be on, you want to have the tab here highlighted for the setup. That way you get both operations. Alright. We want to go up here to turning, and if you do that, you can see all the different turning post processors. Now what I have done is just took the generic FANUC turning, and I have labeled it and saved me one that's just for the G0602, and change some of the parameters here. You can do this by going to open configuration, and if you look at this, these are all the different parameters for that post processor. Now I really can't tell you that I know what all of this stuff means. However, there are some things, like these are user defined properties. These are things that allow you to, when you're in that post processor screen, these are the things that will allow you to change some of those parameters. So right here, I change this to 100 times 24 because the G0602 max RPM is 2400. So I changed that to 24. Also, the default settings, personally I don't like sequence numbers in my G code. Mach 3, if you double click on the G code window, it will put numbers on there for you, but I personally don't like it in my G code, so I set this to false. If you would like this to be default true, then it will put the line numbers, the sequence numbers there for you. You can set the start line numbers. You can increment them by 2 or 1. Optional stop. In between different tools, if you want an optional stop, so you'll have to hit cycle start again, you can set this to true and it will put in default an optional stop. Requires an 8-digit program number. You can set that to true or false. And the rest of this I don't really use. And you can just save this, and when you do, make sure you save it as .cps, otherwise it will not be in here. So it needs to be a .cps file. And that's it. Whoops. Okay. Okay, so these were the user-defined settings that I showed you earlier. I've got mine set to 2400. Optional stop is no. Line numbers, sequence numbers, right here. Show sequence numbers, I have mine set to no. So that's all you need to do, and then once you have that set, you can just click on that every time. So we're going to post these processes for this particular operation. And there we have it. Now what I like to do is, when it's in this screen right here, I like to do some editing. One thing I like to do is, I don't like to use this G28 on the lathe, because what it does is, after the part is machined, it's going to take it to 0, X and Y. And Z0 is way at the end near the tailstock, so I don't do that. It's already going to move it right here. It's going to move X to 6.8, which is away from the stock, and it's going to put Z0, it's going to move Z to 0.1969, which is in front of the stock. If you want, you can move Z a little bit further by doing a G0 Z 2.0, and it'll move it 2 inches. So I like to change that, and I also like to get rid of this G28 right here and type in G95, because I want it to be in the feed to be in per revolutions, and not inches per minute, but revolutions per minute. And that's it. And then we can go ahead and save that and take it out to the lathe and start running our parts. Okay, so in the next video we're going to see how it ran on G0602. So thanks for watching the video. Please feel free to comment if you have any questions. Thumbs up if you like the video. Please subscribe, and most importantly, be safe.